Hello guys, welcome to the series on a practical approach to design and implementation of a PID controller. So in this video we will learn about interfacing the hardware unit that we have built in the previous video with the MATLAB Simulink environment. So we'll do this in two steps. The first step is to measure the temperature from the LM35 temperature sensor, and the other one is to provide a step input to the heater of the real hardware. So before getting into this, we will make a simple, we will understand on how to interface with the Arduino with the help of a simple LED blinker example. So in order to do this, we will need two libraries. One is a MATLAB support package for Arduino hardware, and the other one is the Simulink support package for the Arduino hardware. We can get this on the add-on explorer. And you need one more library, that is the real-time pacer. So the real-time pacer for Simulink. So this is the real-time pacer. What this does is it will slow down the simulation into the real world time. So for example, if in real world 1 minute is equal to 60 seconds, in the simulation also, then the 1 minute will be equal to the real world 60 seconds. So it will slow down the simulation time. So first we will run this. For that we have to first go to the apps. So since I am using a MATLAB 2020A or 2020A version, it will be a little bit different from MATLAB 2018 or 2019. So on the apps, I have to go to the setup to run on hardware, and I have to click on the run on hardware board, and it will ask for me a board, and I'm using an Arduino Uno. I have to click on that, then finish. Then a new block will pop up, a new panel will pop up. So on that I have to click on the hardware settings, and on the hardware settings you can see the hardware board is Arduino Uno as we have selected, and on the target hardware resources we have to click on the host board communication, and we have to set the host board communication, that is we have to set the COM port to the COM port of the Arduino. So I know my COM port is port number 8. So to know this I have to go to the device manager, and under the ports, that is a common LPT, you can see the Arduino Uno is connected to the COM port 8. So that I have to enter over here, and then I have to click apply and OK. And now this is done. So first I am going to test only this, so I will block out I will comment out the other two things. I will right click and I will click on comment out. Okay, so now these two things will not run on the program, and also the stop time has to be infinity, so I have to mention it over here. So till I press the stop button, the whole loop will be running. And I also added a scope block in order to visualize the pulse generated by the pulse generator. You can get these blocks, this one, and this one, from the library browser. Under library browser, Simulink support package for Arduino hardware. Under this you can get all these blocks. Okay, and this block I have defined it to the digital pin number 13. So pin number 13 has a built-in, the Arduino has a built-in LED on pin number 13. So if I actuate the pin, the built-in LED will work. So I will use pin number 13. So now I have to go to the simulation, and I have to click on the run button. So now it's initializing. Okay, now you can see that the LED is blinking. The third LED, that is a single one, is blinking. The other two is for the communication with the Simulink and the Arduino microcontroller. So now the simulation is running for 16, 17, 18. The time of the simulation is run time of the simulation, you can see here. And if I click on the scope block, you can see the pulse generated. Just give me some time. Yeah, yeah. So here you can see the pulse generated by the scope block. So this is how this program works. Now I am going to stop this program. Yeah, yes, the program is stopped now. Now what I'm going to do is I'm going to measure the temperature from the LM35 temperature sensor. So now I'm going to comment this out. Now I'm going to uncomment this. Oops. Okay. Now let me select that. Uncomment. Yeah. Yes. So now I have uncommented this. So what I have done is I have taken analog input, that is a pin from the analog pin 1 A1. I am taking the signal, analog signal, and what I am doing is I am converting the analog signal into a voltage signal. So here I am doing the conversion, and now I have got what I have got is a voltage, but I need a temperature in degrees Celsius. So what the datasheet of LM35 says is that for every 1 degree increment there will be a 10 millivolt change in the voltage. So you can see in this I have put up a link. Yes, you can open this link. Yep, by the components 101 what they have said is there will be increase in 10 millivolt for rise of 1 degrees. So that means I have to divide the voltage that I got by 10. So that is what I have done here. So I have divided it by 10, and from there I get temperature in degrees Celsius. I display it. I have a scope and I have a variable that saves this temperature into the workspace. Okay, so now I'm going to run this. I have the setup connected to the Arduino, and the pin is connected to the A1 of the Arduino. So now let's run this. I hope other things are perfect. Yep. Okay, so let me run this. Okay, it's initializing. Yeah, and now yes, I can able to see the temperature reading from the LM35 sensor. So yeah, so this is the temperature reading that I'm getting. So currently, since the heater is on, like I have on it before, so it is loading, it is showing a higher temperature value. So this is how the LM35 temperature sensor works, how to get the readings from the LM35 temperature sensor. So now I will stop this. I waited for some time till the temperature reading comes to room temperature, till the heater cools down, and I measured the temperature, and it showed 34.18. So that is the room temperature I am in. So now I'm going to show you how to give a heater temperature, heater input. So for now I will comment this. Okay, let it be there. I will do this as well. So I will uncomment it. So here what I'm doing is I'm providing a PWM signal in terms of a percentage. So I'm giving a percentage from 0 to 100 here, and then I'm multiplying with the value of 2.55. So for example, if I give 100, then it will be 255. So that is the maximum PWM value. The minimum PWM value will be 0. If I give 0 over here, then 0 into 2.55 will be 0. So it is nothing but just a linear input. So if I give 0 to 100, then the input to the system will be also a proportional 0 to 255 value. So that is how I'm going to give the input. So and the input is given to a PWM pin number 9 of the Arduino microcontroller. So the MOSFET is connected to pin 9, and to the MOSFET is the heater connected. So I'm saving the value into the workspace, and I'm also visualizing it with the help of a display. So now I will run these two simultaneously, and I will see how the temperature value is being increased. So yeah, so I have commented this out. Now I am going to click on the run button. So yes, So it's initializing. Yes, and it started running. And for 30%, the PWM value is 76.5. So you can see the temperature, it's 34.5. So I will just give a time lapse because it will take time for the temperature to increase. So here you can see reached a steady state over here. Now I will stop the simulation. So the data has been stored on the MATLAB workspace. So I will go to MATLAB workspace. So I will go to the MATLAB workspace and I will click on this output. So this is the output that I have got. Okay, it's loading. Okay, so now I will plot the out dot. So now I will plot the temperature output. Yes, as you can see over the course of time how the temperature has increased. So the output looks something like a S curve. So this looks something like an S curve. So this is all about this video on how to interface the hardware unit with the Arduino with the MATLAB environment. So hope you like this video, and in the next series of videos we will look on how to tune the PID controller. So thanks for watching.